Hello everyone, I'm Deeksha from SVCE and today we'll be talking about the sparse matrix multiplication in data structures and applications. So let's get started and see what all we'll be discussing in today's video. Firstly, introduction, then data structures for sparse matrix representation, advantages of sparse matrix multiplication, applications, challenges, example, and then conclusion. Introduction. Sparse matrix multiplication is an important operation in data structures. It deals with matrices that have a large number of zero elements. Efficiently performing sparse matrix multiplication can save computational resources. Sparse matrices contain mostly zero elements. They are represented using data structures that store only non-zero elements. The data structures used for sparse matrices include linked lists, arrays, and hash tables. Here is an example of a sparse matrix. As we can see, there are a lot of zeros and very less non-zero numbers. This matrix can be represented as a hash table like this one. It shows the rows, columns, and the value of the non-zero elements in the matrix. For example, the first one, the row 0 and column 1 has the value 9. This is the row 0 and this is the column 1. So this element is the value 9. Similarly, row 0 and column 5. This is the row 0 and this is the column 5. It has the value of 4. This makes the representation of a sparse matrix easier. Data structures for sparse matrices. Linked lists. Each non-zero element is represented by a node in a linked list. Arrays. Non-zero elements are stored in an array along with their row and column indices. Hash tables. Non-zero elements are stored in a hash table using their row and column indices as keys. Sparse matrix representation. Compressed sparse row CSR format. Three arrays are used to represent the matrix. The CSR format stores the non-zero elements, their column indices, and the starting index of each row. This format allows efficient access to the elements during multiplication. Advantages of sparse matrix multiplication. Efficient usage of memory. Sparse matrix representation saves memory by not storing zero elements. Faster computation is a second advantage of sparse matrix multiplication. It reduces the number of operations required. The third advantage is that it is suitable for large matrices. Sparse matrix multiplication is particularly useful when dealing with large data sets. Applications of sparse matrix multiplication. Graph algorithms. Sparse matrix multiplication is used in graph algorithms like PageRank. Image processing is a second application. Sparse matrix multiplication is used in image compression and filtering. Third application is machine learning. Sparse matrix multiplication is used in various machine learning algorithms. Challenges. Choosing the appropriate data structure for sparse matrix representation can be challenging. Handling updates and modifications to the sparse matrix can be more complex than with dense matrices. Balancing memory usage and computational efficiency can be a trade-off. Example. Consider two sparse matrices A and B. Multiply A and B using the sparse matrix multiplication algorithm. Show the resulting sparse matrix and compare it with the dense matrix multiplication result. So, to multiply the matrices, we first calculate transpose of the second matrix. To simplify comparisons and maintain the sorted order, so the resultant matrix is obtained by traversing through the entire length of both the matrices and summing the appropriate multiplied values. Anyhow, any row value equal to x in the first matrix and row value equal to y in the second matrix will contribute towards the result. This is obtained by multiplying all such elements, having column value in both matrices and adding only those with the row as x in the first matrix and row as y in the second transport matrix to get the result xy. Conclusion: sparse matrix multiplication is an efficient approach to handle matrices with a large number of zero elements. It reduces memory usage and computational complexity compared to dense matrix multiplication. Sparse matrix multiplication has various applications in graph algorithms, image processing, and machine learning. Thank you.